Hi guys, Mrs. Delisin here. Welcome to another lesson of AP Statistics. Today's lesson is sample means. So we're going to be learning on how to get the standard deviation and the mean of the sampling distribution of sample means. And before we start, I'd like to show you our formula sheets and table. We've already learned proportion. We have already learned one sample proportion, and we also learned two sample proportions, right? And then today we're not going to be dealing with proportions, we're going to be dealing with mean. So the sampling distribution for means has this formula to find the mean and this formula to find the standard deviation. So if you take a look at that, that is a standard deviation over the square root of n. Okay, so let's try to take a look in here. I am not going to be doing the activity with you. I'm just going to be going over the important ideas section and then the check understanding portion. But I would do the activity in class. Okay, so for our important ideas, the sampling distribution of sample mean has the center is the mean of the sample, or the mean of the sampling distribution is equal to the mean. For the variability or for the standard deviation, the formula would be the standard deviation of the sampling distribution of sample mean is the standard deviation of the population divided by the square root of n. For the shape, if the population is approximately normal, let's put approximately normal, then the sampling distribution of the sample mean is also approximately normal. Does that make sense? All right. And every day, people watch 1 billion hours of videos on YouTube. Wow, that's a lot. That breaks down to every single person on earth watching YouTube videos for about 8.4 minutes per day. So if you watch YouTube videos for more than 8 minutes, then that means you're already above average. Okay? So you're already watching more videos than the average person. For US teens, in any given day, the amount of time spent watching YouTube videos is approximately normal, with mean of 18.5 minutes and a standard deviation of 5.3 minutes. Okay, so there's a difference between people here for 8.4 minutes, and then for US teens, which we're gonna focus on, for US teens, it's 18.5 minutes for the mean and a standard deviation of 5.3. Find the probability that a randomly chosen US teen, that's like one person, right? A random person, one person, watches YouTube for more than 25 minutes in a given day. We know it's approximately normal. We have the mean, we have the standard deviation. So right away, we can use the curve. With n is, our mean is teens, 18.5, with a standard deviation of 5.3. So 25 or more, so 25 and above. So when we go to the table, we need to make sure that we are going to do 1 minus the probability that we are going to find. So the formula would be z equals x minus the mean over standard deviation. X would be, what's x? 25 minus 18.5 all over 5.3. That is equal to 1.23. So let's look in our table. Positive 1.23. So we have 1.23 right here. Okay, because 3. 0.8907. So the probability to the left of 25 or to the left of the z-score 1.23 is 0.8907. But I don't want to the left, I want to the right of. So I'm going to be doing, oops, wrong pen. 1 minus 0.8907, that is 1093. Okay, if you're going to use your calculator and go to normal CDF, you're going to get normal CDF. You're going to get, for your lower bound is 25, for your upper bound 1000, mean is 18.5, standard deviation is 5.3. I think you're gonna get 11%, which is the same thing, right? 0.109 is really 11%. Okay, moving on. Suppose we choose an SRS of 10 US teens. So earlier we're solving for one person, right? Now we're solving for 10 people or for 10 teenagers. Let the sample mean, X bar means sample mean. Let X bar the mean amount of time spent watching YouTube videos for the sample. So imagine we have, so earlier for number 1, we want to find out the probability that more than 25 minutes in a given day for a random person. So now take a look at, we're taking 10, right? We're taking 10 people or 10 teenagers, and we want to know what's the probability that the sample mean, right, the average of that 10 people will be exceed 25 minutes. Okay, so we're going to focus on not just a random person, but that 10 people. What's the mean of the sampling distribution of the sample mean? And we know that the mean of the sample mean is equal to the mean. So if the mean is, what's the mean? If the mean is 18.5, then the mean of the sampling distribution would also be 18.5. But the standard deviation is not going to be the same. Calculate and interpret the standard deviation of the sampling distribution of the sample mean and verify that the 10% condition is met. How? Let's do the 10% condition first. 10% condition is that your sample must be less than 10% of the population. So our sample 10 is that less than 10% of all, I think it is, way, way less of all US teens. Okay, so that's good. And then we are going to, oh, maybe I'll have to write that small because I have to interpret. So 10 is less than a tenth of all US teens. Okay. And now for my standard deviation, I would have to use the formula that I found over here. So the square root of, so the standard deviation of the sample mean is that standard deviation divided by the square root of n. So our standard deviation right now is 5.3. I'll divide that with square root of 10. And that is going to be 1.676. So this is the standard deviation of the sample. And then, what are we going to do? We are going to interpret that. So this is the mean number of minutes spent watching, can I just say YouTube, YT? YouTube in a sample of 10 US teens typically varies by 1.676 minutes from the mean of 18.5 minutes. There you go. Now we have our same mean, but a different standard deviation. Find the probability that the mean amount of spent watching YouTube for the teens in the sample exceeds 25 minutes. So we're going to do the same thing what we did earlier, also more than 25 minutes in a given day. But right now, we're not gonna be using the same standard deviation, right? Hopefully that is making sense. So I'm going to be solving for same mean 18.5, but my standard deviation is no longer the same. So that is, where's 25? In this case, the standard deviation is very small. So my 25 would be like not even that small, like really small, crazy small. Okay, so z equals the sample mean minus the mean over the standard deviation. Okay, so my sample mean would be 25 minutes minus 18.5 over 1.676. That is 3.88. And I want to the right, so I'm going to do 1 minus that number. So let's go to, where do we go? To the table A. So let's go to table A. What was that? 3.88. That's a really big number. Very big z-score. Okay. Unfortunately, we do not have 3.8. Unfortunately, I said that twice, I know, because I want to make a point. It is the highest z-score that we have on the positive is only 3.4. And we want all the way here, we want 3.88. And it's not there anymore because that percentage is highly unlikely. And because 3.88 is not there, we are going to be using the biggest one available for us, which is 0.9998. Okay, so I'm going to subtract that from 1 because I want it to the right. But I would like you to take note that it is not a 3.88, but it's a 3.4. Okay, so let's see what we're going to do here. So let's go back. In the table A, I would have to do 1 minus, because I wanted the right side, 0.9998. I want to make sure that I got same amount of 9. And 1 minus that would be 0. Count how many twos? 0.0002. So technically it's 0.02%. It's very unlikely. Okay, and I don't want, my answer is not really 0.0002 though, because remember the 0.0002 is for 3.80, 34. And so my answer should be not that, but less than. So if I'm going to be asked, what is the probability that the spent time watching YouTube for teens in the sample exceeds 25 minutes, the probability is less than 0.002. I said less than because this is 3.4, but I needed 3.8. That would mean that the answer is really low. So every time when you have a table, when you go to table A and then the z-score that you're trying to find is not there, you use the last one and you would just say that the answer would be less than that. If we do it in the calculator though, we are able to solve it in the calculator. So we're gonna do normal CDF 25, 1000, 18.5, 1.676. I think when you do that in the calculator, you will get 1, 2, 3, 4, 5, 3. This is the real answer, right? So it's true that this answer is lower than that answer. Okay? And both are acceptable. If you say this in the AP exam, you're good. If you say this in the AP exam, you are good. For as long as you said the correct number. Like, Miss, does it really matter that I just said that my answer would be less than 0.0002? It doesn't matter, because what that's saying is that your answer is highly unlikely. Okay? That's it, you guys, for today. I hope that this video will help you out with understanding how to get the standard deviation and the mean of the sampling distribution of sample means. Thank you, everyone. I'll see you guys in the